Hi, today we are going to see how to create a project using Spring Data JPA with custom query. So let us directly dive into the project. I have created a Spring Boot project. This is the project structure. As usual, how we used to create a Spring Boot project with these dependencies. I have taken Spring Boot Dev Tool dependency, MySQL driver dependency, and starter dependency. Along with that, we need a data JPA dependency. So starter web, dev tools, connector, and we need a starter data JPA, Spring Data JPA dependency. With these dependencies, you have to create a Spring Boot file. Don't worry, the same project for sample I will give in the description. You can take it from the GitHub. So here, this is the project structure. If you could see, this is my project overall structure. So here, this is our main file, and this is the controller. Inside the entity package, we have a product class, and inside the repository, we have a product repository interface, and inside service, we have a class. All other things except this repository is a class. Repository alone is an interface. Here is the application properties. As we are using data GPA, I have configured my database. With B30 is my database name, and these are all my user credential for the database. I have given update so that whenever I am repeating my project execution, the data, whatever is there in the database, will not remove. It will just get updated in the existing data. Either you can add new rows or you can delete new rows according to your project execution. And because of this true statement, whenever we are executing the query, we in the console, we could see that the queries are displayed. So that's why, see, for example, select product like this, what we will be doing is in the console, whether you want to see the SQL queries or not. If you want to see the queries, then for show SQL, you have to give true. If you don't want to reveal the queries, then you can mention there as false instead of true. And here the port number I have configured as 8084. For making my Hibernate to connect with the MySQL, I have chosen a dialect of MySQL 8 dialect. But according to the recent version, you can change the dialect as MySQL 5 or even only MySQL dialect also will work good. So according to my project version, I have taken it as 8. If it is not supporting in your machine, according to your Java version, you can change it to MySQL dialect also. Next, this is my entity class. So my entity class product is inside this entity package. I have added an annotation at entity to make this class to be mapped into the ORM as a table. These are all the variables I have created, only cast, name, and ID. And if you could see, I have a normal Pojo class with the default constructor, parameterized constructor, get a set of methods. And here is my repository. So it is an interface, as I've told you. In this product repository, I have extended a JPA repository. To this repository class, I have mapped my entity class. So product, I have mentioned my entity class is product. So after specifying here, what is your ID field? My ID field data type is int. So here it accepts only the wrapper class. So we are giving integer as a data type of the primary key field of your table, which is going to be generated for this product class. So these queries, let us come back. And here in the product service, I have used a few queries, a few methods to generate or call the previously predefined methods, which is available inside the JPA repository. Here, if you could see, I am connecting this product service with the repository using a dependency injection. Here I performed a field injection. So now the repository bean is connected with the product service class. This find all method and all is already available inside the JPA repository. So this and all already we have discussed in another video. So please have a look into this. If you could see in this JPA repository, these are all the predefined methods. If you could see, there is a find all method, find all sort methods, get one method, get by ID method, save all. These methods are predefined. In the JPA repository, we need not write the logic. That's why to the repository, whatever we have created here, we have just extended the JPA repository. So the product service, what we are doing is usually the project structure goes like this. Repository will be directly connected only with the service, where in the service we are going to write the logics of doing all the efforts or all the context, whatever you want for your application. And the controller is mainly for only creating a mapping request, either get mapping, post mapping, put mapping, delete mapping kind of request you can make only from the controller. So service part, now we have extracted to the service class. So here for the service class, let us add an annotation as service. You could see in some projects, service will be an interface and there will be a service implementation class, where for the service implementation class, the methods declared in the service will become a base. All the implementations, we will give it in the implementation class. So here, if you could see, as I've connected the repository, I'm just taking this repository object and I'm calling the predefined method find all. Similarly, for finding any product only using the ID, there exists a method called as find by ID. What we are doing is repository dot find by ID. The parameter we have to pass here from the URL path. That value will get substituted here. In case if that particular ID is not present in the database, then it will throw null. So this find by ID and find all and all is a default predefined queries available in the JPA repository. Whereas comes to the custom query, you could see find by name, find by cost, the find by age. These methods and all not by default available in the JPA, because these variables and all related to the context of our own application. In such cases, we have to write the logic for fetching the data from your database using custom query. So for making these kind of find methods only, here in the repository, we have written few definitions for the methods. So let us see one by one. First, in the custom query, we have different types of queries. Let us say it has a JPQL, Java Persistence Query Language, native query, and derived query. If we are writing a JPQL query, then the query name should be like if my variable, for example, let me show you. If my variable in the product class is name, then the corresponding query when we are writing here should be there in the same variable. In front, there is a convention to add find by. In case if it is variable name is cost, then here what you can do is the variable name is cost. In front, we can add it as find by cost. Let us say if there is a age variable here, then we can have here as find by age. Like this, we can write our predefined queries. It's very simple. So here the method is there and we have to pass the name. Using the name, we are going to find the product from the database. So here is the query, a normal MySQL query where I have given with select some product P from the product table. This is the table which is created using the JPA for our product class. As this is the product class, we know Spring Data JPA, because of this entity annotation, will map this product class into a table, where in the table we are going to have, so assume this class, product class is going to be converted into a table. So class name is also product, table name also will become a product. As we are having three variables here, the table also will have three columns. First column for ID, next column for name, and next column for cost. So like this, the table will be created, and number of rows depends on number of products you are going to create it as an object for this product class. So this is how the JPA basically works. When I want to find certain item using the product name, so what we have to write the query is select P from product P, where P dot name is equal to that wildcard we are using, where in the wildcard, see actually this we call it as a prepared statement. In MySQL, you might have studied something as a prepared statement when you are writing the query in the JDBC in the Java language. So here I make it as a prepared query. Now I am saying that what is the field I have to take here is the first field. So as per the index, it is 0 and this is 1. So this value I need to be mapped in this place. What is the value I want to map? This name. This variable value will come and map here. First parameter, whatever I am passing is going to be passed here. So that is the meaning of this query. Just if you write the query, that's more than enough. Compiler and the Spring Boot will automatically understand as this is a custom query, the query to be executed is given above. So this query will get executed in the MySQL and according to the name, the product will be fetched. The same way, find all method is a predefined method. Yes, that's well and good. Now, if you are writing a customized query for find all method, this is how we have to use. Again, the same annotation as at query. What is the value? What is the query you are going to pass? That query you have to give here. That makes the difference between your JPQL and the query here. So here directly let me give it a select star from product because we want to fetch all the products. Here I am saying this is a native query by this attribute. What comes the next another type of query is the derived query. So here if you could see this query and this query almost same, differs only by the variable name. Here I have written a query for find by name, whereas here I have written a query for find by cost, which spans for these two variables. One is for name, another one is for cost. Here, as we are going to find by name, the parameter is name, and as I'm going to fetch the product based on cost, here my parameter is cost. But here I have written the query in JPQL, but in derived query, I didn't write anything, but the system by itself now it's understood that, okay, for this cost with this variable, the system is now ready to generate the query on its own. So let us see how it executes. Already I have executed the project. Let me show you how the other classes are. See, here is the product service class. This product service class is calling that get products method. So here if I'm keeping in parallel, it may be easy for you to compare. This is product service, repository is my repository is here. Let me close the XML. Yes. Fine. So here first I have connected the service class and the repository by auto-wired. I did a dependency injection. Next, for get products, directly we can call the find all method. And for get product, find by ID method, which is already predefined available in the JPA repository. Get product by name. What we are doing, we are just invoking the method repository dot find by name. Where is that method? This method is here in line number 16. Inside the repository, there is a method find by name. We are just calling the repository dot find by name by passing the parameter name. So this value goes and gets substituted here and the DB will take care of the rest of the works. Similarly, next method is get product by cost. So what we are doing here is we are going to invoke from the repository. Now I'm calling the find by cost method. So what is this find by cost method? Already we have written that we need a method, a find by method for the cost variable using a derived query. Fine. So now the system is smart enough to generate the query for finding an item based on its cost. Hope the mapping is clear. What is the purpose of service method? Service method is only going to invoke the methods present in the repository. Now, this is how I have made all my getter methods. A normal find all for listing all products. One method for finding an item based on ID. Another method for finding an item based on its name. And another one for finding an item based on the cost. So here, if this is the service thing, then what the controller is going to do? Here, in the controller class, we could see, as I've told you, controller is only for mapping the request. where I'm just only invoking the service class methods here. So if you could see, here the works goes like this. There is a get product method here. Yes. So here is my get product method. What I am doing here is I am mapping a get mapping. I'm calling that service class get products here. A simple method call only. And similarly for finding an item based on its ID here, I'm writing a same get product method here. I'm mapping the request here as it is a get mapping. Here in the path variable, I'm going to pass this ID variable value. If it is a product by cost, here is the product by cost method is there where I have to pass the parameter as cost. Now you could see here is the mapping method for get a product by cost. Assume here in the URL, we are going to pass the cost. So if I am passing cost in the URL, I have to use this endpoint. If I am passing or searching an item based on its ID, then I have to use this endpoint. If I am searching or filtering some item based on its name, then I have to use this endpoint. So controller is for making differentiation among your endpoints, among your mapping requests, like which service method actually we are going to pick. That is the main purpose of having a controller. So let us go for seeing the output. So here in the console, already my application I have started. Application is running in port number 8084. Let us go here. So here, if you could see the 8084, if I'm using the end product, end point as get products, you could see these are all the items. Two items I have in my database. First one is Lakme and the second one is iTech typo. Okay. So two items are getting displayed. So this is get products means find all method. You get what I'm saying? Get products. You could see the get products method. This one. Service dot get product. Here. So what happened is it is finding out all the items in the database. Next one is 8084 slash, let us say how, based on an ID. For example, if I'm fetching any item based on ID, get product. So if I'm giving 2, it fetches the second product. And if I'm giving 1 based on the ID, it is going to fetch the item. So Lakme ID number is 1. Next, let us assume that I want to search a product based on the cost. So if here I'm giving the cost as 0.0, so it is fetching the item items. Let me say the cost of the item is 1000, so it will be fetching the item Lakme. And last one is getting a product by name. So let me say if I'm searching for an item based on the name, then that corresponding item alone is get fetched here. In case if I want to search for the other item, so here you could see that it is giving here. In case if I am searching for any item or any product which is not there, So what will happen? The corresponding request is not having any value, so it is returning null. So it is returning null. This is how we can customize the query based on the variables. See, usually for ID, automatically JPA is having a predefined query. For other kind of variables such as age, salary, result, height, weight, let us say in the popular e-shopping apps, we are seeing filtering items based on the range of price, cost of price. For such things, we have to write the custom JPA query. I think like the video is clear for everyone. The code for the entire project is given in the description. You can take it from the GitHub with the same environmental setup. Yes, you can run the project. Thank you all.